Hello everyone, welcome back again. In this video, we are going to look at the problem word ladder from Leetcode. So firstly, let us go through the problem statement. It is given that a transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words starting from the begin word and ending at the word end word. Okay, so the transformation is such that every adjacent pair of words differ by a single letter only. Also, after the begin word, every word in the transformation sequence should be present in the word list. It is not necessary that the begin word should be a part of the word list, but every word after the begin word should be from the word list only. Okay, and the last word of our transformation sequence should be the end word. Okay, so we'll be given two words, begin word and end word. Along with that, we'll be given a dictionary of words called word list. We need to return the number of words in the shortest transformation sequence from the begin word to the end word. And if it is not possible to reach the end word, then we need to return 0. Okay, so this was the problem statement. Now let us see the approach and understand this problem in detail. So this problem seems to be hard apparently, but soon you will understand that how simple it is to solve this problem. We basically need to find the shortest transformation sequence from the begin word to the end word, and we need to return the length of that transformation sequence. So let us consider this small example first. In this case, our begin word is AC and the end word is KO, and this is the dictionary of words that we are having. So starting from the begin word, let us see what are the different transformation sequences possible. Every other word in our sequence should be from this word list dictionary only, right? So as you can easily see that this transformation sequence is the smallest one and the length of this sequence is 3. So in this example 3 we need to return. This is what we need to perform in our algorithm. Now let us consider another example and see the approach to solve this problem. So whenever we have a scenario where we need to find the shortest path from a starting node to a target node, then in such cases we usually prefer breadth first search algorithm. Why? Because BFS is such an algorithm which helps us to find the shortest path and reach our target destination. In this case also, if we consider our begin word to be the starting node and our end word to be the destination node, then using BFS we can easily reach the end word in the smallest possible steps, and that's what we need to find. So in this problem we'll be using BFS algorithm to find the length of the shortest transformation sequence. So let us consider this example and dry run our algorithm on this. Here you can see the begin word is ape and the end word that we want to reach is man, and this is the dictionary of words that we are having. Whatever transformation we are performing, each word in that transformation except the begin word should be a part of our dictionary. We should keep this in mind. And also in the constraints it was mentioned that all the words in the word list are unique. So in a particular transformation each word can only appear once. Now as we all know, in BFS we need a couple of data structures. For instance, we need a queue, first in first out queue. Along with this queue we also need a set which will include all the words in our dictionary word list, because while performing our algorithm as we include each word in a transformation, as we consider each word, we need to make sure that we don't consider the same word again, right? And for that we will remove that word from our set data structure. So let us begin implementing our BFS algorithm. The begin word is ape, so we will push this begin word in our queue. Now next what we are going to do is, since the length of the queue currently is 1, so we are going to pop one time from our queue, and on popping we are going to get this word ape out of it. Now we need to find all the possible transformations from this word. So the next word in our transformation sequence should be, which is the word adjacent to this word. That word should only differ by one character from this word, right? So for each position in this word, we are going to consider all the characters from A to Z. Okay. For each position, we are going to change the character at that position to all the characters starting from A to Z. And on doing so, new words will be formed. So firstly, we are going to change the character in the first position, which is currently A. So we are going to check in our set that how many words are there that end with PE. As you can see, there is no word that ends with PE. It means that it doesn't matter which character we substitute in the first position, we are not going to find any word which is present in our dictionary. So we are going to move to the next position. Now we are talking about position 2, second position. So we are going to check again. One by one we are going to try all the characters from A to Z. So words that start with A and end with E. So as you can see, again there is no word. It means that no matter what character we substitute in the second position, we are not going to come up with a valid word that is present in our word list. So again we will move to the third position. Again we are going to substitute all the characters starting from A to Z, and one by one we are going to check each new word formed. How many words that start with AP are present in our word list dictionary? So on checking, as you can see, there is one word that starts with AP and ends with T. It means that if we substitute T in the third position, we are going to get this word, and it means that it is a valid word and we can use it as our next word. So that's why we are going to add this word in our queue. We will then remove this word from our set because we have already used it and we don't want to use it again in our transformation sequence. So we will remove it. And as you can see, there is no other word that starts with AP in our dictionary. Now we are done with the word ape. So we will move to the next level. So actually it means that we are also going to take a variable. We can name it as level, which will keep the track of the length of the shortest sequence. Right, we need to return the length of the transformation sequence. So we can take a variable level, and in the beginning we can initialize it to 1, and now that we are moving to the next level, we can increment it to 2. Now in the next level, again we are going to find the length of our queue. So as again the length of the queue is 1, we are going to pop one time from our queue and we will get this word apt. Okay, so again we will do the same thing. One by one we are going to consider each position in this word and we will substitute all the 26 characters from A to Z in that position. Firstly, we will consider the first position and we will check how many words are present in our set that ends with pt. So as you can see, opt is one word that ends with pt, and it is the only word. It means that in the next word in our transformation can be opt because it differs by only one character from the word apt, right? So we are going to add opt in our queue. Okay. At the same time, we will remove it from our set because we don't want to use it again. Then we will move to the next position, which is the second place, and we will substitute all the 26 characters one by one, and we will check how many words are present in our set that starts with a but ends with t. Starts with a but ends with t. As you can see, there is no other word, so we will move to the next, and again we will check how many words are present in our set that begins with ap. So as you can see, there is no other word that begins with ap. It means that again there is no other valid word to add in our queue. We are done with this word apt, and we will move again to the next level, which means that we will increment our level by 1. Now we are talking about the third level. Now again the length of the queue is 1, so we will pop one word from our queue. Now the current word is opt. Again, one by one we will consider each position in this word, and we will substitute all the 26 characters one by one, and we will check for the valid words from our set. So firstly we will see how many words are present that ends with pt in our set. So as you can see, there is no word that ends with pt. It means that no matter which character we substitute in the first place, we are not going to get any valid word which is present in our set. That's why we will move to the second position in our word. Now we will substitute characters in the second position, and we will check how many words that ends with t and starts with o are present in our set. So as you can see, this word begins with o and ends with t. It means that it is a valid word, and this word can be the next valid word in our sequence. Hence we are going to add it in our queue, and as we discussed, we are going to remove it from our set. And also there is another word that starts with o but ends with t. If we substitute the second character with a, we will get ot. So we can add, this is also a valid word, and we can include it in our queue, and we will remove it from our set. And there is no other word that starts with o but ends with t, so we will move to the third position in our word. Now we want to look for the words that start with op. As you can see in our set that there is no word that begins with op. Hence no matter what character we substitute in the third position, we are not going to get any valid word which is present in our word list dictionary. So it means that we are done with this word, and we can move to the next level. We will increment our level count to 4. This time the length of our queue is 2. It means that we are going to pop twice from our queue. So firstly we will pop this word out, which is OWT, and we will keep repeating the same process. Firstly we are going to substitute characters in the first position, and we will see how many words are present in our set that ends with WT. Since there is no word, it means that we need to move to the next position. Now we will check for the second position by substituting 26 characters one by one. So we will see how many words are there that ends with T but begins with O. Since there is no word, now we will check for the third position. How many words are present in our set that begins with OW? Again, there is no word that begins with OW. It means that from this word there is no other valid word. So we are done with this word. Now again we will pop for the second time. Next word that we get is oat. Again, one by one we are going to consider all the positions. So firstly we will check for the first position. How many words are present that ends with AT in our set? So as you can see, this word mat ends with AT and begins with M. So if we substitute character M in the first position, we will get MAT. It is a valid word. That's why we can add it in our queue. And as you can see, we will remove this word, and as you can see, there is no other word that ends with AT in our set. We will now move to the second position. Now we will check how many words are there that begins with O but ends with T in our set. So as you can see, there is only two words and none of them begins with O and ends with T. It means that there is no valid word. And we will move to the third position of this word. Now we are going to check how many words are there that begins with OA in our set. Since we have one word that begins with OA but ends with N, it means that it can be a valid next word. So we can add this word in our queue and we will remove this word from our set. And since there is no other word, it means that we are done with this word oat. Okay. And again we will move to the next level. Now this time again, since the length of the queue is 2, it means that we are going to pop twice from our queue. So the first word that we will get is mat. Again, one by one we are going to check each position in this word. We will try to substitute each position from the 26 characters one by one. So firstly we will check for the first position how many words are there that ends with AT in our set. Since there is no word that ends with AT, it means that there is no valid word. We will move to the second position. How many words are there that begins with M but ends with T in our set? Since there is no word that begins with M and ends with T, it means that again there is no valid word found. And we will check for the third position now. In the third position, one by one we are going to substitute 26 characters and we will check for the new words. If that word is present in our set, it means it is a valid word, right? That's what we are doing. So we need to check how many words are there that begins with MA in our set. Since we have this word man which begins with MA, it means that it is a valid word and we are going to use it. But while we check for the valid words, if a word is found in our set, we are going to check one more thing. If that word is the end word, we are straight away going to return the length of our sequence. Since we have found our end word, we can return 5, which is the length of the shortest transformation sequence. This is how BFS helps us to reach our destination in minimum number of steps. We don't need to continue our BFS further because we have already found our target word. And if I talk about the time complexity, for each word, let's say the length of a word is n, and for each position we are trying all the 26 letters in that position, so times 26. And again, after substituting the new letter, we will get a new word. And let's say that word is a valid word which is present in our dictionary. So then we are checking if that word is the final word or not. So again, times n, because comparing two words is linear time. So this, and along with that, let's say there are w words. At max there are w words in a particular level, so we need to perform this w times. So our time complexity becomes 26 times n square w. So since 26 is constant, so we can ignore it. That was it. Now let us quickly move to the coding section. So this is the Java code. Firstly, I have taken is present boolean variable and initialized it to false. This variable will help us to know whether the end word is present in our word list or not. If it is not present, then it means that there is no possible way to reach the end word, and we will return 0. Here I have taken a set available which will keep all the words from our word list. Set will help us to quickly know whether a word is present in our set or not. Then one by one, from our word list, we are adding each word in our set available set, and also we are checking if that word is equal to the end word. We are making our is present variable to true. Alright. Then after that, after adding all the words in our set, here we are checking if our is present variable is true, then we are going to continue. Otherwise we will return 0, because our end word is not present in our word list dictionary, right? But if it is true, we are going to continue. Here I have taken a queue data structure, first in first out, and in the beginning I am adding the begin word in our queue. And I have taken this net variable, which is basically the level count, to keep track of the length of the transformation sequence, shortest transformation sequence. Then while our queue is not empty, we will continue our BFS. I am finding the length of the queue in each turn, and that many times I will pop out words from our queue. So let's say current is the word which we popped out from our queue, and firstly I will check if that word is equal to the end word that we want to reach. If it is equal, then we are straight away return the net variable count, which is the level count which we are currently at. If it is not equal to the end word, then what we are going to do is, for each position in the word, we are going to substitute all the 26 characters starting from A to Z. And so here I have firstly converted that word in an array of characters. Then I am substituting in that position, I am substituting the new character, and the new word that is formed, I am checking if that word is present in our set available set. If it is present, it means that that word is a valid word, and we will add that word in our queue. Okay. And then I will remove that word from our available set so that I don't use it again. Like this, we will find all the valid words and we will add them in our queue. And we will repeat the same process for the next level and so on. And each time we are going to increment our net variable, which is the level count, which we are keeping. And as soon as a popped word is equal to the end word, it means that we have reached our destination and we can return net. Okay. And if somehow it is not possible to reach the end word, then we will return 0 at the end. And on submitting this, this code will get accepted. So you can go through this code. It is a pretty standard BFS algorithm, nothing else. So that's all for this video. I hope the concept was clear. If you are new to this channel, please consider subscribing and also share it with your friends and juniors. Thank you.